Hi, hello, welcome back to Intermediate Studies. Today we dive into Physics First Year Unit 2 Units and Measurements. These are the 2 mark questions from Unit 2, which are small in size but big in scoring power. So let's break them down with smart keywords. Let's get started.
Here is the first question. Distinguish between accuracy and precision. Accuracy. Accuracy is nothing but how close of our measured value to its true value. Whereas precision gives the closeness of several measured values. Because if you see the accuracy definition, accuracy is defined as the degree of closeness of the measured value to its true value. For example, if our true value is 10 and our measured value is 9.9, so it will define the closeness between the measured value and the true value between 9.9 and 10. So that will give the accuracy. Whereas in precision, here we need to take the multiple readings, for example, our readings are like a 0.21, 0.22, 0.23. So multiple values are there. So based on the multiple values, if we will check the closeness between the values, that will give the precision. See, precision is defined as the degree of closeness of the several measured values, and accuracy depends on errors, whereas precision does not depends on errors. And the next question, distinguish between fundamental units and derived units. Very simple question. The units of fundamental physical quantities are called fundamental units, whereas the units of derived physical quantities are called derived units. If you want to elaborate more clearly, like you can define what are the fundamental physical quantities, like such as length, mass, time, whereas fundament derived physical quantities or velocity, force and energy, that is not required. This is just an optional. You can simply write units of fundamental physical quantities are called fundamental units and units of derived physical quantities are called derived units. For this you will get 1 mark. And for the example like meter, kilogram and second, definitely you need to mention the example for each of the units. For fundamental units you need to write the example meter, kilogram or second, etc. For derived units also you need to definitely mention the example Newton, Joule or Watt, etc. You can write 1 or 2 examples, that is also enough. And this is one additional point, like there are 7 fundamental quantities, and hence 7 types of fundamental units exist. But whereas in derived units you are having several derived quantities, so you are having several derived units. So this is totally optional, no need to write this, just keep in the mind the definition and the example. Yeah. Now look at the third question. What are the different types of errors that can occur in a measurement? Basically, we are having 3 types of errors. One is systematic errors, and the second one random errors, and the third one is gross errors. And furtherly, the systematic errors are classified into instrumental errors and personal errors and imperfection in experimental techniques or procedure. Or else simply you can mention experimental errors, because while experimenting, like imperfection in experimenting technique or procedure, which is also known as experimental error. You need to answer all these errors, and if you will remember, then you can mention the systematic errors also, just instrumental, personal errors and experimental errors. And how can the next question, and how can systematic errors be minimized or eliminated? Just now we already read the systematic errors that are occurred. One is instrumental errors, personal errors and experimental errors. So to overcome the instrumental errors, just we need to select the better instrument, and to overcome the personal errors, just we need to avoid the personal bias in taking the reading. And to overcome the experimental errors, just we need to improve the experimental techniques. Very simple, right? So we need to know what are the systematic errors and how we need to overcome those systematic errors by selecting better instrument, by avoiding personal bias in taking reading, and improving the experimental techniques to avoid the experimental errors. And the next question. Here the fifth question. Express unified atomic mass in kg. And here one unified atomic mass U is equals to 1.66 into 10 to the power of minus 27 kg. Definitely in kg. Here the question is asked to write the unit in kg. So you have to written the value in kg, and don't forget to write the unit for this atomic mass unit. So unit is very important. It will, if you haven't written this kg, then definitely they will remove 1 mark. In sixth question, the velocity of body is given by v is equals to at square plus bt plus c. If t and if v and t are expressed in SI, What are the units of A, B, and C? Here in the question, they are asking three units for like three units. What is the unit of A? What is the unit of B? And what is the unit of C? And don't forget to write for these three variables. And see, from the principle of homogeneity of dimensions, the units of V, AT square, and BT and C are equal. So from the principle of homogeneity dimensions, the whatever the variables we are having here, so for all those variables in that expression are equal. So SI unit of AT square is equals to SI unit of V, and SI unit of BT is equals to SI unit of V, and SI unit of C is equals to SI unit of V. So we can write so we can equate any of the variables like this. So by taking SI unit of AT square is equals to SI unit of V. So what is the unit for T? What is the unit for time? It's a seconds, right? So A into S square is equals to, what is the unit of velocity? Velocity is nothing but distance by time. For distance, the units is meters, and for time, the units is seconds. So the unit of A is equals to meter per S cube, which means a second cube. So this is your first answer. The unit of A is equals to meter per S cube. So the next one, SI unit of BT is equals to SI unit of V. So what is the unit for time? Seconds is equals to SI unit of V is nothing but distance by time, meter per second. So what is the finally, what is the unit of B? Meter per second square. So this one is your second answer. The unit of B is equals to, if the S comes here, so it will become meter per second square. So the third question, SI unit of C is equals to SI unit of V. So finally, what is SI unit of V is nothing but meter per seconds, right? So finally, unit of C is equals to meter per seconds. This is your third answer. So definitely right. Finally, you can mention like the SI units of A is this one, the SI unit of B is this one, and the SI unit of C is this one. So that's it. In this video itself I included problems also, so don't skip any of the problems, all are very simple only. But please concentrate into the problems. So see, the error in measurement of radius is 1%. What is the error in the measurement of volume? They already given the error percentage of radius in sphere, but they're asking to calculate the error percentage in volume. So we already know what is the volume of sphere. Volume of sphere is 4 by 3 pi r cube. So they mentioned the error in the radius of the sphere is delta r by r into 100 is 1%. They have already given. So we need to calculate the error in volume. What is the volume of sphere? Because we are talking about the sphere, right? So we need to take the volume of sphere. So volume of the sphere V is equals to 4 by 3 pi r cube. Here 4 by pi is the constant values, right? So V is directly proportional to r cube. This is the main formula that you need to write in the examination. So finally we need to calculate the percentage of volume. So delta V by V into 100 is equals to, after performing the differentiation for this V, for V is directly proportional to r cube, we will get 3r square. So based on some calculations, just see, you can based on some calculations we will get this formula, but don't need to do all those things. Just remember the whatever the power we have on the variable that will come forward. So that's the reason we are taking delta v by v into 100 is equals to 3 into delta v by, sorry, delta r by r into 100. So they have already given the value of delta r by r into 100, that is 1%. So simply 3 into 1, 3%. So that is your final answer. You have to don't forget to mention the percentage symbol after 3, because we need to calculate the percentage of the error. So definitely mention the percentage unit. So finally you can write the error in the measurement of volume is delta v by v into 100 is equals to 3%. So next question, the percentage error in the mass and speed are 2% and 3% respectively. What is the maximum error in kinetic energy calculated using these quantities? What is the formula for kinetic energy? Half mv square, right? So let's look into the answer. Percentage error in the mass is 2% and the speed is 3%. So just write those values. Percentage error in mass is 2%, which means delta m by m into 100 is 2%. And next, percentage of error in speed. Speed is nothing but velocity. So percentage error in velocity is 3%. Delta V by V into 100 is equals to 3%. So what is the formula for kinetic energy? K is equals to half mv square. So just write down this formula. And here if you see, they mentioned mass and velocity, right? Here half is the constant, so k is directly proportional to the mv square. So after performing the differentiation concept and all, so finally we will get delta k by k into 100 is equals to simply delta m by m into 100 plus addition of these two variables. So delta m by m into 100 plus the power will came forward, so 2 into delta v by v into 100. So finally, the delta m into 100 is 2% plus delta v by v into 100 is 3%. Just substitute those values and you will get answer as 8%. And don't forget to mention the unit of percentage symbol here. It will deduct 1 mark. So definitely remember to add the units for your answer. Next question. What are the significant numbers and what do they represent when reporting the result of a measurement? Remember, they will ask like significant numbers or significant figures or significant digits. So just you can answer like significant figures is nothing but the digits of a number that are known reliably plus one uncertain digit are called significant figures. What is the meaning of known reliability? Which means simply we can say as natural numbers. Natural numbers is nothing but it will starts from 1 except 0, right? So the natural numbers all are significant figures only. So the digits of a number that are known reliably plus one uncertain digit are called significant figures. Here the significant, they have asked one more question: what do they represent when reporting the result of a measurement? Simply the significant figures indicate the precision of a measurement, that you need to mention. Okay, here they asked two questions: what are the significant numbers, so you need to define that. And he asked what do they represent while reporting the result. So for that one you need to write it will indicate the precision of the measurement. That is the second answer. So the next question: what are the significant numbers? Write the number of significant digits in the measurement of 0.002308. Here they're asking for the significant numbers. We have already read in the above question, right? Just answer this definition and the number of significant digits in this number. So here if you see, what are the natural numbers here? 230, sorry, 238, but here the 0 is indicating in between the natural numbers, so we need to take care of that 0 also. So including that 0, the total we are having four significant numbers: 1, 2, 3, 0, and 8. So the number of significant digits in the measurement of this number are 4, including 2, 3, 0, and 8. So don't skip the 0 here, you need to include that 0 also. And the next question: why do we have different units for the same physical quantity? Of course, because we are having different systems of measurements like CGS system, MK system, FPS system, and SI system. Hence, we are having different, because we are having different types of systems. So that's the reason we are having different units for the same physical quantity. So just we need to mention that only. Just give the few system names like CGS system, MK system, and SI system, like that. If you mention the example, then it will create a good impression on you. For see here, milligrams and grams and kgs etc. for mass, because for mass is a physical quantity, right? For single physical quantity we are having different units. See, for some things we can measure it in milligrams, for some things we can measure in grams, for some items we can measure in kgs. These are the different units. So different units we are having for different physical for the same physical quantity. Physical quantity is same, but we are having different units. And here is one more example: millimeters, centimeters, and meters and kilometers for length. Length is one physical quantity. For the same physical quantity we are having different units like millimeters, centimeters, meters, and kilometers. It will create a good impression if you write the example here. And here two more problems are there, which is really important, not very important, but you need to go through these problems also, because these are the rarely asked questions, so you need to look into that. See, A physical quantity x is related to four measurable quantities a, b, c, and d as follows. This is one expression: x is equals to a square, b cube, and c to the power of 5 by 2 and 2 to the power of minus 2. And here the percentage error in the measurement of a, b, c, and d, or they are given the error percentage of these variables 1, 2, 3, and 4 percentage respectively. And what is the percentage error in x? They are asking to calculate the percentage of error in x. Very simple, right? So percentage of error, x is nothing but delta x by x into 100. We need to calculate this one. So just after differentiation, we will get like this: 2 into delta a by a into 100 plus 3 into delta b by b into 100 plus 5 by 2 into delta c by c into 100, and plus 2 into delta d by d into 100. The same thing we are writing here. Very simple, right? This is the formula. 2 into the same thing, just the powers or will came forward and just adding up all these variables. See, and finally we are substituting the value of errors they have given, just 1% and 2%, 3%, and 4%. Just substitute all these values and calculate, and finally you will get delta x by x into 100 is equals to 23.5%. And don't forget to write the unit here. That will give 1 mark. And the next question: the measured mass and volume of the body are 2.42 grams and 4.7 centimeter cube respectively. So here the mass is given and the volume of the body will be was given, and with the possible errors of 0.01 grams and zero point 0.1 centimeter cube. With possible errors means mass error they have given and the volume error they have given. Just write up the, and they're asking to calculate the maximum error in density. Okay, so we need to calculate the error in density. So first write up the values what they have given. So mass value is 2.42 grams and the volume is 4.7 centimeter cube, and possible errors, which means delta m is 0.01 gram and delta v is zero point 0.1 centimeter cube. So mass and volume values and their respective errors we are having. And what is the formula for density? Mass by volume, right? So after performing the differentiation here, differentiation u by v we have to apply. So delta rho by rho is equals to delta m by m plus delta v by v is equals to, so just substitute all the values which we already have. Just substitute all the values, then finally you will get the value for delta rho by rho. But they are asking to calculate the error percentage in density. So percentage error in density means we need to multiply the answer with 100. So delta rho by rho into 100 is equals to 0.24 into 100 is equals to finally 2%. Here we are just taking 0.02 itself to simple the calculations. So finally the error percentage in density is 2%.
These are the important questions and problems from Unit 2, Units and Measurements. If you found this helpful, please like, share, and subscribe to Intermediate Studies. Let's keep cracking physics together in upcoming videos. Thank you. Thanks for watching. Bye bye.